Okay guys, so in the previous lesson, Mr. Thomas Wick showed you how to graph quadratics when they were in standard form. That is the most common form, and we've already graphed them from intercept form, which is when it's factored, back in Unit 5. In this lesson, I'm going to show you how to graph it from vertex form. Vertex form is your form that looks like this. A times x minus h squared plus k. And it's your form that's more focused on the transformations. So way back in Unit 3, we talked about transformations of functions. Remember, we said at that time that if you add or subtract inside parentheses, then that's going to move your function left and right. If you add or subtract outside parentheses, that moves your function up and down on the y-axis. And then if you multiply, then that's either going to do a stretch if you're multiplying by a number larger than 1, or a shrink if you're multiplying by a number less than 1. And then, of course, negatives do that reflection. They flip it over the x-axis. So if you look at vertex form, this is on your formula sheet, and it looks like this. Y equals a times x minus h squared plus k. So I'm going to show you what all these pieces mean, but also if you think of it through the lens of that transformation that we talked about in Unit 3, it might be a little bit helpful. So the first thing you're going to do is you're going to start by putting the vertex, which is h and k, in the center of your table. So whatever value is right here is going to go in the middle of your table for the x. Whatever value is here added on to the end is going to be in the middle of your table for your y. Notice that I'm pulling the opposite of that h. That's for the same reason we've talked about before. Anything that's happening in parentheses, you kind of pull the opposite, because we know that we would really set that equal to 0 and solve. So I would end up with positive h. All right, so I'm going to do a quick example as I go along with these steps. So my vertex for this one, I'm going to pull a positive 1 and put that here, and then a 3. That is going to be the vertex of my quadratic, and I like to plot the points as I go along, just so that if anything starts looking strange, I can catch that right at the start. Right, and then the next thing you're going to do is you're going to construct a table of values for the x and the y. So very similar to how you did for standard form. Once you've got that vertex, you're going to count backwards and forwards from that value to figure out numbers, or to figure out ordered pairs for your tables. So back from 1, I'm going to go 0 and -1. Ahead of 1, I'm going to get 2 and 3. So then I'm just going to start plugging those in. Make sure that you get your y-intercept in there, because it's just a nice piece of information to have. So even if when you count back and forwards 0 doesn't end up showing up in the table, you should probably add it just so that you have that information. So when I plug in -1, I'm going to have 2 times -1 minus 1 squared plus 3. Now you really got to pay attention to your order of operations, which means I'm going to do what's inside the parentheses first. Just write that there in case you're having a moment. All right, so I'm going to subtract what's inside that parentheses first. -1 minus 1 is -2 squared plus 3. My parentheses are done, so now I'm going to move to exponents. Do not multiply that first. You'll get it wrong every time, and you won't understand why. -2 times 2, or to the second power, is equal to 4. Positive 4, not negative. If you're using the calculator, make sure you put it in parentheses. 2 times 4, now I'm ready for multiplication, so I do 8 plus 3, which is 11. So at -1, I'm at 11. It's technically off the graph, but you know, I know it's going to be right here above that 10. Then I'm going to plug in 0. This is going to get me my y-intercept. So I'm going to do 0 minus 1 squared plus 3. Every single time I'm just plugging it in for x. Nice thing about the vertex form is all your x's are consolidated into that one spot, so you really just have to plug it in once. So I have 2, 0 minus 1 is -1 squared plus 3. -1 squared is positive 1. So I get 2 plus 3, which is 5. So my y-intercept is 5. If you want to be writing some of this information down as you go, that's fine. So the vertex we've already got is 1, 3. Because we know the vertex, we also already know the axis of symmetry. Remember, the axis of symmetry is always going to be the value of your x coordinate of the vertex. So my axis of symmetry is at x equals 1. So if I wanted to draw my little reflection line here, or my axis of symmetry, it would be right there. I haven't found my zeros yet, but I do know my y-intercept because I just plugged in 0. And I got 5, so I know my y-intercept. I also can go ahead and put my domain because that is always going to be all real numbers. The range and everything else we'll get in just a second. So if you want to save that for last, that's fine. I like doing it as I go. All right, so now I'm going to plug in 2. I'm going to come over here and say 2 times 2 minus 1 squared plus 3. You may want to have some scratch paper for this because it admittedly does take quite a bit of paper. All right, so 2 minus 1 is 1 squared plus 3. 1 squared is 1. So I get 2 plus 3. Now, I want to point something out here. I am getting 5. The same thing I got when I plugged in 0. That's because I have this reflection point here where I was 1 space away and I was at 5, so away from the axis of symmetry, I'm going to have a 5 as well. Once you get really good at this, if you want to just reflect your points, that's fine. For right now, though, it's good practice to just go ahead and plug at least another one in so that you can verify that you do get 5, because that's a self-checking measure. That lets you know that you got your vertex right, you didn't mess up looking at this negative here and pulling the opposite. It lets you know that you didn't make any errors. If I got 5 2 times, then I can feel pretty confident that 5 is really where those ordered pairs are supposed to go. So it's just a way to kind of check your work from previous in the problem. So I'm going to go ahead and plug in 3. And 3 minus 1 is 2. 2 squared is 4. And I get 8 plus 3, which is 11, which is exactly what I expected because I had 11 here, and this is going to be symmetric. So 4, 11 is going to be up there. All right, now the last thing the steps say to do is connect the points with a U shape. So here we go, ladies and gentlemen, going to try to do a parabola. Started to realize that I do better if I do it as 2 separate curves. That's not too shabby. All right, so let's fill in the rest of the characteristics that we haven't talked about already. Extrema is just asking you, is there a minimum or a maximum value to this? So is it opening up or is it opening down? Well, this is opening up, so I have a minimum, and the minimum is that vertex of 1, 3. So minimum at 1, 3 is my extrema. I know that it's going to be a minimum because I didn't have a negative A. Remember, a negative would reflect it and make it open down and have a maximum point. So I could have predicted that it was going to be a minimum just by looking at my A value here. My zeros, well, this never crossed the x-axis, so I have no zeros. And that's okay. Remember, you can have 1 solution, 2 solutions, or no solution. So you tell me however many times it crosses the x-axis, that's what you're going to write down. Your range in parabolas is always going to be dependent upon where that vertex is. So my y values start at 3, so I'm pulling the y value from my vertex, and it continues up forever from that 3. So y is greater than or equal to 3. It does equal 3 because when I plugged in 1, I get 3. And then it goes up forever from there. And that's number 1 done. All right, so notice that this parabola has been shifted to the right 1. You know, your parent function would just, let me real quick sketch it. Your parent function is going to look something like this. Okay, so this function has been shifted to the right 1 because I subtracted 1 inside parentheses. It's been shifted up 3, so I went over, up 3 to put it up at 1, 3 as a vertex. And it's taller and skinnier than your parent function. That's because it's had that vertical stretch of 2. So those transformations, you can really see how they might be another tool to help you check your work as you go. All right, so let me real quick get to a second example for you. I won't go into as much detail here, but it's going to work the same basic way. All right, my vertex is going to be -2, 4, because I take the opposite of what's inside. I'm going to fix that 4. Ugh, I don't know why the 4s are always horrible. There you go. Okay, so I'm going to take the opposite of what's inside parentheses, because if I set it equal to 0, I would subtract 2. So my vertex is -2, 4, and I can plot a point at -2, +4. All right, then I'm going to count backwards, so I go -3, -4. Here I get -1 and 0. And I'm going to plug in these values. So make sure you keep that negative in front. I'm going to do this in a different color. So make sure you put that negative in front, and then I'm putting -4 + 2 squared. I think it has something to do with the way I write my 4s. I got to get better at that. There we go. -4 + 2 squared + 4. Okay? Inside the parentheses, I get -2 squared + 4. -2 squared is 4, but I've still got that negative out in front. Keep track of him. So +4. -4 + 4 is 0. So I get 0. So that means at -4, 0, I have a point. Now I'm going to plug in -3 squared. All right, -3 + 2 is -1 squared + 4. -1 squared is +1. -1 + 4 is 3, and that makes sense because it's showing that I have, yeah, there we go. -3 is 3. That's fitting with this, that's fitting with this curve here along this line. All right, so now when I plug in -1, I expect to get 3. I'm going to do it just to make sure, but I expect to have a mirror image of 3 over here because remember, my axis of symmetry is right along this line. So my axis of symmetry is x = -2. I expect to see a point of 3 here. So let's go ahead and plug in -1. -1 + 2 squared + 4. -1 + 2 is 1. And 1 squared is 1. -1 + 4 is indeed 3. So I got my reflection point. And when I plug in 0, -0 + 2 squared + 4. 0 + 2 is 2. 2 squared is 4. So I still have that negative out front, and -4 + 4 is indeed 0, which is what I expected because that's the mirror image of this one. All right, now my next step is to connect those points. Preferably yours will go through the point. Oh my goodness. Preferably yours will go through the points a little bit better than mine did. I'm going to blame the cat. The cat hit my hand. It wasn't just me. All right. So now let's fill in the other information. My extrema, I have a maximum point because it's at the top. My maximum point is at that vertex of -2, 4. I had a negative out front, which means I knew I was going to have a maximum point because this parabola got reflected. My zeros are at -4, 0, and at 0, 0. So anywhere I see zeros in the y, those are my points, but you can also see them on the graph. My y-intercept, also 0, 0. So that point's playing double duty here because I'm crossing the y-axis there as well. My domain, always all real numbers. My range, this y value starts at 4 and is equal to 4, but then it goes down from 4. So y is everything less than 4. Again, if you look at your transformations, that parent function we know got shifted to the left 2 because I've got +2, so that's going to go to the left 2 and then up 4, and then it was also reflected. All right, that's really it. I'm sorry for yet another long video, but at least there's only one this time. So go ahead, try this example. Please, please, please check your answers as you go, and then as soon as you know you can do one correctly, go ahead and start your practice. You guys have fun graphing from Vertex Form. I really like it, and we'll talk about how to transfer from one form to the other in the next lesson. Bye.